Hey everyone, this is Tim. I'm going to show you today how to do some electrical wiring. I'm going to thank my dad for this. Taught me everything I know about residential electrical wiring. Today I'm going to be installing a dimmer and a speed control for a paddle fan. This particular situation, I've taken this box apart, taken the old switches out, and found that there were some problems with it that I'm going to need to fix before, that are pretty common, that you might run into quite frequently if you're trying to replace a switch like this. It's a newer house. It's less than 20 years old, so the wiring is fairly new. And so I'm going to go about the other thing about this particular splice, and I don't necessarily recommend this, is that I'm going to be doing this with the power actually turned on. Like I said, I don't recommend it. I would recommend turning the breaker off, or unscrewing the fuse, or whatever you have to do to turn the power off to the circuit before you do this. But sometimes circumstances do arise where you may have to work on it with power. Like I said, I don't recommend it. But as an electrician, we did have to do that frequently. And I don't know, an example, I guess one might be if you're in a big apartment building or something with a lot of old wiring, and you just have no chance of locating where the circuit lines originate and what turns off what, and you don't want to shut off power to the entire building. That might be an example. But I'm going to show you how to be careful when you're doing it, and make sure you stay safe around electricity, and hope you learned something. So I'm going to zoom this in on what I'm doing here. I just gotta adjust the camera real quick. Okay. Hopefully you can see that. So what I've got here is I've got a two gang box. I've got a feed coming in. I've got wiring already set up for a paddle fan. I've got a 14 3-wire going out up to the paddle fan. In a 3-wire system, you have a black wire that usually goes to the fan. You have a red wire that's typically for the light on the fan. In this case, somebody did a splice, and I have two feeds coming off. Both these wires with the red wire nuts on them are live right now. Each one of those is going to power up one of these two devices. This one will be for this one here will be for the speed control. This one here will be to control the light. And then of course we also have the bare ground connection, which is right here where all the grounds are spliced together. So the first thing I noticed when I took this apart was I guess whoever wired the house initially was not very attentive to detail when it came to making sure that they protected the integrity of the insulation on these individual wires when they initially did this splice. And I don't know if you can see it here. It's a little tough to see. Maybe I'll try and zoom in a little bit, but no, not really. But anyways, what I've got here is I've got bare copper showing through this where this insulation has been cut. I've got it on this red wire, I've got it on the switch leg on this black wire. And what that's usually from is when somebody's stripping the white insulation off the Romex wire when they're entering into the box, back when the house was being wired and the walls were all exposed and everything. Slice down the insulation with their utility knife or regular knife or whatever, went too deep, and cut the individual conductors, the insulation on the individual conductors inside the Romex cable. Now, I've looked at these and I can see that the actual copper wire is still intact. It hasn't been cut, it hasn't been broken on both of these. So the wire is fine. It's just the insulation is just slightly damaged. So if it was actually a break in the wire, if the wire looked like it was shaved and it was too thin, I might actually cut those, and I might actually splice a wire onto them to extend them. But in this case I don't really have to, so I'm going to just take a piece of electric tape and just wrap that spot. Just wrap that spot where there was the cut in the insulation, and that'll be fine. And I'm going to do the same thing. And use enough tape that it's going to hold on there. Wrap it tight, pull it, actually stretch it a little bit, so you get a nice tight stuck section of tape. Okay, so that's pretty good now. The other thing too is a lot of times when you take splices apart, the wires are going to be a little twisty on the ends because of when you crank down these wire nuts, it tends to twist the wires a little bit. You always want to take your pliers and you want to straighten those out nice and good. Got that one there. I'm going to do the same thing on this switch. This is something else that a lot of times you'll encounter on the newer switches, newer meaning the last 20 years or so. They've had these push-in connections on the back. These are fine. There's nothing wrong with these. But if you're not going to be wiring an entire house where you have to do 100 receptacles or 100 switches, and it's just a matter of efficiency, you really shouldn't use those. And the reason is because with usage, the wire actually expands and contracts every time electricity goes in it. It's a minuscule amount, but over time it can actually loosen up that connection, and it can actually, if there's a little bit of an arc in there, it can actually damage the switch. And I actually noticed that this switch, somebody put that connector in, and when it pulled out, the side of the switch was actually broken. And so now that breaks off, and now the wire can just basically come right out, and then it's just loosed inside the box. So what I'm going to do with this, these are they're tough to get out. I don't usually recommend getting them out. It's usually pretty kind of a pain in the butt, but they have these little slots on the back. You can push a thin screwdriver in there and kind of work the wire out, and it will come out. But I would not recommend using that method to try and get the wire out if the power is on to anything. But because your screwdriver, you touch the metal, and if you're touching a live wire, that inside there is also live. And if you touch the screws on the side, those could be live. So I recommend you just keep away from everything and just snip the wire off. So once I get the wire off, like I said, take your pliers, straighten the end a little bit, just kind of get it so the end is nice and straight. That's going to be our speed control. So I'm going to keep that. And this is another good thing to remember, is if you want to try and keep track of the wires, bear in mind when you're doing it where the switches are going to be. So if usually the switch for the light is closest to the door, and the speed control would be farther from the door in this case. So I've got my feed for the speed control, I've got my switch leg for the fan. I push those over to the side the switches are going to be on. I've got my light that's going to be turned on by the red wire. I've got my feed for the dimmer I'm going to put on here, the switch. I move those to the left side where those are going to be. Now they're separated, they're easier to keep track of, and it helps avoid confusion in the end. These particular dimmers I'm using have a ground wire. The dimmer and the speed control have a ground wire on them. It's not required that you ground. I mean, even regular switches have a green ground wire on the side of them. It's not required that you ground them in a situation like this where I'm just working in a bedroom, because there's very low chance you're going to be encountering any water or anything like that, so you don't necessarily have to ground them. But in this case, this is the speed control here, and you can see it has a green wire coming off of it for a separate ground that is crimped right onto the metal plate on the front of the speed control. And that is the ground. It doesn't have any bearing on how the thing works. The speed control will work absolutely fine without the ground connected, so will a dimmer. It's just a matter of security. It's just sort of like an insurance measure. This metal plate on the front of here, if it were ever to get shorted inside the speed control, if there was a short and something live inside there were to contact this plate, then that could be electrified, which would then electrify the plate screws that screw into these holes, which then are on the front of the plate. You touch the switch, you hit the screw. If the paints were off the front of the screw, you can get shocked. So the ground is there. It might not stop you from getting shocked, but with the ground there, as soon as something shorts out and makes a connection inside this plate, the ground is going to trip the breaker immediately. Okay, so I'm going to start putting this together now. I'm going to start with the grounds because it doesn't involve any live electricity. You can see that when they sprayed paint in this room initially, they spray the primer all over and it tends to go all inside the box. Just to be sure, when you do these bare grounds, you want to make sure there isn't paint all over these wires before you make this splice. In this case, they're pretty clean. There's a little bit close to the end, but for the most part the wires are clean. So you don't have to be paint on there, otherwise you're basically nullifying the effectiveness of the ground. So I see that they're twisted together nice. I don't have any concerns about the splice coming apart. Another thing that it's important to know is that these wire nuts that you use to cap these splices, first of all, always use at least a wire nut. When I took some splices apart in our house, the previous homeowner had just spliced the wires using regular electric tape. That is not an effective splice. It's not safe, and I'll tell you why. To just use tape or something that's soft like this, the reason why you want a hard wire nut, a plastic wire nut, or some sort of hard connection is that, just like I mentioned with the switches, that not necessarily with the ground, but with the wires that are actually conducting electricity, they're going to expand and contract a little bit each time. Maybe not each time, but over time they'll expand and contract, and in doing that, that can actually loosen up that splice inside that tape. That's one thing. The wire nut holds it together nice and securely. The other thing is that if you just got tape on there, what happens too is if you've got a wire, say you've got your splice and it's taped together and it's up against, you push these back in a box and it's up against the side of the box on the inside, and all you've got is tape around that splice. Well, your kids are banging around the house, people are banging around the house is shaking, and every little time it could shake, that wire could move just a little bit inside that box. And over time, because the tape is soft, it wears right through it, and what you got then is a bare wire, bare splice inside the box, and you got this nice shiny bare ground wire here just waiting for it to contact the side of the box and cause a short, which will cause a blast, which should be contained within the box, but you never know. It could start a little bit of a fire and it could escalate from there. So main reason not to use tape to be the only thing that you use to splice wires together, for high voltage I should say. If this was a metal box, it'd be even more of a concern, because all I have to do is wear through that tape, touch the metal box, boom, and you get a blast. You'd trip the breaker, but it would blast first. So, alright, so I'm going to show how to put this together. Before I hook this up, just so you can see it easier, I'm going to show you that on every dimmer and speed control, there's a top and bottom. I had to. I'm replacing the. I'm repositioning the dimmer that the previous homeowner put in here because they put it in upside down. There's no reason to do that, because every single one, if you can see, up in the top here, has an arrow that says up. Pretty self-explanatory. Face that up. Now these things that are on the front, these metal plates, they actually do serve a purpose. They actually is a heat sink, because dimmers and speed controls, because they're monitoring the the power that's going through them up to your device, your light, your fan, or whatever, they can heat up. And so they put these on here as a heat dissipation device, and they have these fins on them. Now you can actually modify these, and I might have to do it here, but we'll see. Sometimes when you put these in a box, those fins will hit together, and you can't get them close enough to be able to put the plate cover on. Well, I'll show you if I have to, but if I don't, just in case I don't, I'm going to explain a little bit. All you have to do is you can take your pliers and you can actually grab these and just bend them and snap them right off. And it's not going to harm it if you just got an average light fixture or something. If you got something that's 1,000 watts, you might want to reconsider this. I think these dimmers only go up to 600 watts, but if you have something that's real high draw, you might want to consider not taking these fins off. But for the average light, it's not really going to present a problem. So once you take those off, you can actually then put these together, and you can overlap them, or you can butt them up against each other, and that way they can go together more tightly. So anyways, I'm going to start, like I said, I'm going to start with the grounds. We've got to hook both the grounds together. We've got the grounds that are coming off these switches are stranded wires, which means they're made up of smaller strands that are twisted together. These are solid wires, so we've got 3 solid ground wires that are twisted together. Best thing to do in this case, these are a little long, but best thing to do in this case is to take these strand wires and just twist them together first. I mean, there's no reason they can't be. Twist them with your pliers. Don't try and just do it with your fingers, because you just can't do it. And you're going to take this and you're going to hold these, make sure that the live wires are out of the way and protected with wire nuts or tape or something. And just take these strand wires, take your pliers, really kind of mesh them into the strands of the bare ground wires coming into the box a little bit. Make sure you use a wire nut that's big enough size that can accommodate the splice. Hold the wires together, twist the wire nut on, go pretty far. With a splice that has a lot of wires in it, you may need to really just crank on it a little bit with your pliers, just like that. Get a couple more turns, really tighten it. Make sure those wires cannot come out. So the ground splice is good. We're gonna kind of put that off to the side. All right. So now I got my speed control here. I got my dimmer here. I'm gonna do the speed control first. Again, keep in mind which display is up. Turn this over like this. I'm doing this live, so I'm going to connect the switch light first that has no power on it. Another thing I should mention is that it does not matter which one of these wires on the back of the speed control you connect to what. They have no dedicated function. The power just goes in and comes back out. It doesn't matter which one you use. So I'm just going to pick one. I'm going to strip maybe about 3/4 of an inch of the insulation off that switch leg wire. I'm going to take the stranded wire from the speed control and I'm going to wrap it around there real good so that the length of the stranded wire is equal to the length of the stripped wire that I just did. A lot of times these speed controls come with their own wire nuts. They're generally pretty good. These ones look like good ones. What I would advise you to do is, if you look inside this one, you can see that there's actually a metal spring inside there. For doing bigger high voltage splices like this, or maybe not a big splice, but just doing high voltage splices like this, I recommend that you always use a wire nut that has that spring inside. Sometimes you'll get cheaper ones and it'll just be plastic threads in there. Those don't work as good. They don't hold. You can strip them off real easily when you're screwing the thing on there. So I recommend, if you use the ones that it comes with, make sure they have the spring inside. If they don't, I mean, what's it going to cost you? It costs you a few bucks. Get them at the store. Get a package of $50 or whatever. It'll cost you $3 and you'll have enough for the rest of your life. Unless you're an electrician. But, so, put that on there, screw it on nice and tight. Twist the stranded wire in a little bit with the solid wire coming out of the box. So now the switch leg is hooked up. Now, this is a speed control. You're not supposed to wire these live. It says it right in the box. I'm sure it says it on everything, don't wire live. I'm doing it just as an example, and I'm going to show you that I have the speed control is in the off position, so that when I touch these wires there's not going to be a draw on it, and it's not going to burn out the speed control. Again, this live wire, it's a little kinked on the end. There's power running through it right now. I'm going to use my pliers. I'm going to make sure my hands are not touching the exposed metal part of the pliers. And I'm going to straighten that wire out. Now it's nice and straight. It'll make a good splice that way. Got the wire nut here. Got the wire nut. Going to twist this on the power wire, the hot wire. Again, I can touch it with my fingers. I sound weird because with the wire nut in my mouth. I can touch it with my pliers. As long as I got good rubber shoes on, I'm not standing in water, I'm not touching the bare ground wire, I can make this splice with it hot. Now that it's hot, I can actually try it. Alright, the fan is turning, so that's good. Get that out of the way. Now I'm going to do the dimmer. Same thing. Look for the up arrow. Found it. It looks to me, I don't know if they're all like this, but it looks to me like the bottom of the switch, the speed control, or the dimmer is where the wires come out. I'm not sure if that's the case in every case, but with these two, it is. So now, got my red wire. Again with the dimmer, it doesn't matter which one of these black leads you connect to what wire. One goes on the hot wire, the other one goes on the switch leg. Make sure the dimmer's in the off position. Straighten out the stranded wires coming off the leads on the dimmer. Get my wire nuts. Pick that up. Twisted those up good. Twist the stranded wire in with the solid. Pull on a little bit, make sure it's tight. Didn't mention that before, but now we're gonna wire the hot side. This wire looks pretty straight, so I'm gonna use it as it is. Again, you're touching these live wires. You don't touch the bare ground. You don't touch any part of the metal on the front of that dimmer or the speed control when you make the splice. If you do, you get shocked. Hold the wires together. The wire nut on. Get nice and tight. Twist those together. Give a little pull. Make sure the lead from the dimmer doesn't come out. Test the dimmer. It looks like it works. So now, all the splices are basically safe. You still want to be careful, obviously, but I'm going to push those back in there. Just push the ground back in there first. Feed splice pushed in. Switch leg pushed in. These don't have to be perfect. You just want to get them out of your way. And we'll see if we have to push those back. So now, we're going to do a bit of a test run here. Push all that back in there. Got a little extra drywall here. Do a test run, see if whether or not they're going to fit in the box. It looks like they probably will. One last check to make sure they're both facing up. The screws that came with the speed control, these are 632 screws. They match the threads on the screw holes in the box. All device boxes, switch boxes, they all use the same type of screw, and they all have the same type of thread pattern. Lights are different. They're 832 screws, light fixtures, but in this case we don't need those because we're doing switches. So what I'm going to do is I'm going to get each one started. Just get them started loosely. You don't want to tighten them both down all the way right away, because then you can't really reposition the switches here and there to make sure that they fit in the box properly. So you got that. Some people use screw guns to do this. I guess you could if you're doing a lot of these, but I'm only doing the one. So okay, so now you want to get your switches nice and straight. Tighten them as much as you can, but not too hard. You don't want to squish the drywall. You don't want to squish the switches too much. Alright, it looks okay. Now I gotta take the knob off the speed control so I can put the plate on. And make sure the plate lines up with the screw holes. And that's a little tight. You gotta get, see, we've got to get this one to move over, but it won't. And this is a good example. It'll show you that you might have to take, it really might be necessary to take those foils, those heatsink foils off the one side. Loosen this. You don't have to take it all the way out. We just loosen that one. I mean, we do have to take it all the way out. I thought those would go together, but okay, that's good enough. So, to get that out, we take our pliers, bend those a little bit, they snap right off. That's fine, there's nothing wrong with this, it's not breaking the device, it's not modifying it in a way that it's not designed to do. Okay, so now put this back together. And you just saw there was an example of that these are I forget the exact term for it, but they're like quick snap or quick thread boxes where you have little things in there and you can actually just push the screws in and they snap. It helps it so you can push the screws in most of the way, and then you just finish tightening them at the end. And it helps out a lot when if you're wiring houses or something and you've got to do hundreds of these boxes. You can actually, if you have to, you can actually take a hammer and tap them in, and then you finish screwing it the rest of the way with your screwdriver, just to get that last little bit at the end. Okay, so those are probably a little better. The other thing too is you don't have to really crank down on these screws. It's okay if the switch kind of floats around a little bit, or if it moves, if you're having trouble lining up these screw holes. Right now it looks like I got it pretty good. So I'm going to go ahead and put these screws in. Now you don't have to, another thing is you don't want to tighten each screw as you put it in. You want to leave them, just get them started. That one's being a little finicky, so just get them started like this, so you can still move the plate around a little bit, so you can start the other screws. You get that one started. You get that. It's a good example right there. Is it didn't quite line up. Not perfect. It'll work. You just get them started here. Kind of lines the plate up. So I scratched the drywall a little. I didn't mean to do that. Just hope that goes in there. Yeah. Okay. So line that up. Don't have to crank down these screws. It's only a plastic plate. My dad always liked to make them look nice and neat, so he taught me good. I do the same thing. I always make sure the slots in the screws all face the same direction. Just kind of makes it look a little neater, a little nicer. Okay, we take our switch for a dimmer, we put it back on there. Inside of the knob on the speed control has a little flat side. It's working. Hope this helps you out. Be safe. Good luck with your electrical.